Okay, let's look at this more complicated example and how to find instant centers for all the linkages here. So how many linkages we have? We have 1, 2, 3. It's the same linkage, 4, 5. So 5 different linkages, which means we have 5 rigid bodies. Okay. How to find instant center for each rigid body, which means here we should have 5 instant centers. Okay, let's first find out all the easy instant centers. Of course, all the points that's anchored to the ground or ceiling or the wall should be the instant center. So here, instant center for this rigid body HG. Point A must be an instant center for rigid body BA. Point F is the instant center for FD. Okay, so we spot 3 instant centers already. So now we have left with instant rigid body BD. We don't know instant center for that. We also don't know the instant center for GE. Okay, let's start with the instant centers we have. So we've been trying to find instant centers. What instant center can tell us? Instant center is the center of rotation, right? We mentioned if you connect the line, find a point, connect that point to the instant center, that line should be perpendicular to its direction of motion. So in other words, if you know instant center, you can use that instant center to determine the direction of motion. In other words, direction of velocity vectors. So, for example, we know the instant center, point H is the instant center for HG. And that means we can use that instant center to determine velocity vectors at any point on this rigid body. So here we have a point G. We can connect point G to its instant center, which is this bar HG. And that line HG should be perpendicular to the velocity vector. There you go. This is our direction of motion at point G. And it's also the direction of velocity vector. Here I draw up or down because I don't really know if this bar is going counterclockwise or clockwise rotation. If you know that information, you can determine if this is going up or down. But that's okay, since we don't really need to know exactly up or down, as long as we know the general direction. That's okay. Okay, so now we use that to figure out direction at point G. We can use the same way to use this instant center to figure out direction of velocity at point B. Same thing here. If you connect point B to its instant center, velocity vector at point B must perpendicular to that line, connection line. And so this is going to be our A B. We can use the third instant center to find direction of velocity vectors at point D. So connect point D and F, draw a perpendicular line. Those lines tells you direction of motion at point D. That's 90 degrees. Okay. So instant center is very helpful. They help us to identify direction of motions at any point on that rigid body. Okay. So now we figure out 3 instant centers. We figure out 3 points, and we know their direction of velocity. Okay. Now we can follow the steps to find out instant center for this rigid body BD. Okay. It would be a little bit hard to figure out rigid instant center for this rigid body because we know nothing about that point E. But we're pretty sure about direction of velocity at point B and point D. We already have that drawn out here. So that means we can easily start to find out instant center for BD. Okay, follow the steps. First step, find 2 points. Here we have B and D that we know velocity direction. Second step is you start to draw lines perpendicular to its velocity vector. Let's draw lines perpendicular to this velocity vector. In this case, would be just extension for the FD, extension for AB. These 2 lines give us a intersection right there. This is the instant center for rigid body BED. Okay, so now we know 4 instant centers. We have one last instant center we need to figure out. Where's the instant center for EG? If you're trying to apply the 4 steps to this rigid body EG, you're gonna stuck at point A of step 1, excuse me, because we only know direction of velocity at point G. We have no idea about direction of velocity at point E. And we can't proceed, we can't draw lines, we can't find intersection. But one thing we can do is we can observe that point. We realize that point E is not only the point on this rigid body EG, it's also the point on this rigid body BD. And we just find out where's the instant center for this rigid body BED. And what we can do with instant centers, we can use instant center to figure out direction of motion at any point on the rigid body. So we can use this instant center right here to figure out direction at point E. How? Okay, remember what you did to find direction at point G, B, and D. You simply connect those points to its instant center and you draw a perpendicular line. That's how you find direction of motion. Same thing here. Where is the instant center for point E? Again, this point E is also on this rigid body BED. We know instant center is here. So we can draw a line that's connect instant center to point E. The velocity vector or motion of direction must perpendicular to the line we just draw. So here 90 degree. In this direction, it tells us velocity at point E. Okay, now we know velocity at point E going to this direction. Yeah, now we also know point G going up and down. How to find an instant center for rigid body EG? Follow the steps. Step 1, figure out 2 points, know velocity direction. Step 2, draw lines that's perpendicular to those velocity vectors. Find out the intersection, which is here. At that point, it's the instant center for GE. Now we have all 5 instant centers for this linkage system.